In this video, we are going to be looking at how to use algebra in order to find equivalent ratios. But before we look at this, we need to make sure that there are a few topics which we are confident with. The first one is solving quadratic equations, both in the form where our coefficient of x squared is equal to 1, as well as when the coefficient of x squared is greater than 1. The second topic that we need to be confident with is solving and simplifying algebraic fractions. So if you're not confident with any of these topics, I will put a link in the description box for you to have a look at. So in this question, we are told that given x squared to 2x plus 4 is equal to 1 to 2, find the possible values of x. So normally when we are given a ratio, for example 1 to 5, and we have another ratio which is equivalent, for example 2 to 10, we can write this as 1 to 5 is equal to 2 to 10. Another way we could write this ratio is in a fraction form. So we could write 1 over 5 is equal to 2 over 10. So this is the same principle that we are going to be using in order to solve these questions. So first, we can start by writing our equivalent ratio in a fraction form. So instead of x squared to 2x plus 4, we're going to write this as x squared over 2x plus 4 is equal to, and because the ratio is 1 to 2, we are going to write it as 1 over 2. So what we have done is we have now formed an algebraic fraction. And because we are finding the values of x, that means we are solving for x. So we can solve this by cross-multiplying it to make it a linear equation. And this will give us 2x squared is equal to 2x plus 4. If we now move everything onto the left-hand side, this will give us 2x squared minus 2x minus 4 is equal to 0. Because all of our terms in this equation have a common factor of 2, we can divide all through by 2, and that will give us a simplified equation, which is x squared minus x minus 2 is equal to 0. Now we need to solve this quadratic equation, which means we need to find two numbers which give us a product of minus 2, and the same two numbers need to add to give us minus 1. So looking at the factors of just 2, we have 2 and 1, but because we are multiplying to get a negative number and adding to get a negative number, that means our bigger number 2 would have to be negative 2 and 1. So we can now factorize this as x minus 2 and x plus 1. This is now in a factorized form, so we can solve it by putting it equal to 0. And if x minus 2 is equal to 0, that means x is equal to 2. And for the second bracket, if x plus 1 is equal to 0, that means x is equal to minus 1. So these are our two possible values for x. This question says, given that x squared to 10x plus 15 is equal to 1 to 5, find the possible values of x. So again, we are going to write each of these ratios in a fraction form. So we have x squared over 10x plus 15 is equal to 1 over 5. To solve this, we are now going to cross-multiply these to make it into a linear equation. So we will have 5x squared is equal to 10x plus 15. If we now move everything onto the left-hand side, we will have 5x squared minus 10x minus 15 is equal to 0. Because all the terms in this equation are divisible by 5, if we divide all through by 5, we will be left with x squared minus 2x minus 3 is equal to 0. So we now need to look for two numbers that multiply to give us minus 3, and the same two numbers need to add to give us minus 2. The factors of 3 are 3 and 1, and because we are adding to get a negative number, and multiplying to also get a negative number, that means the bigger number, which is 3, would have to be negative. So we can now factorize this as x minus 3 and x plus 1. To solve it, we put it equal to 0. which means that if x minus 3 is equal to 0, x is equal to 3. And if x plus 1 is equal to 0, x is equal to minus 1. The next question says, given that 2x plus 6 to x plus 3 is equal to 3x plus 9 to x plus 4, find the possible values of x. So we are first going to write both the ratios in a fraction form. The first ratio will be 2x plus 6 over x plus 3, and the second ratio will be 3x plus 9 over x plus 4. And these are both equal, which means we now have an algebraic fraction which we need to solve. So we are going to cross multiply to make it linear. So now we have 2x plus 6 multiplied by x plus 4 is equal to 3x plus 9 multiplied by x plus 3. If we now expand the brackets, we will have 2x squared plus 8x plus 6x plus 24 is equal to 3x squared plus 9x plus 9x plus 27. So now we've gotten some like terms on the left-hand side that we can simplify. So we can rewrite this as 2x squared, 8x plus 6x is 14x, and then we can put the plus 24. And we can also simplify some terms on the right-hand side. So we can rewrite this as 3x squared plus 18x plus 27. So in order to solve this quadratic equation, we have to make it equal to 0. So this whole side, we can move it onto there. And this would give us x squared plus 4x plus 3 is equal to 0. Which means we are now looking for two numbers that multiply to give us 3. And the same two numbers need to add to give us 4. The factors of 3 are just 3 and 1. And they also add to give us 4. So we can now factorize this as x plus 3 in one bracket and x plus 1 in the other bracket. And to solve it, we put each bracket equal to 0. So if x plus 3 is equal to 0, that means x is equal to minus 3. And if x plus 1 is equal to 0, that means x is equal to minus 1. Now we have a worded question that says, Alice and Bob share some candies in the ratio 2 to 5. Alice gives 80 candies to Bob, and now the ratio is 1 to 3. How many candies does each initially have? So what we have been given is the ratio of candies that they had. So we could put A for Alice and B for Bob, and write this ratio as 2 to 5. Now we have to remember that the ratio is just a simplified number of the initial amount of candies that they had, which means that the ratio of initial amounts had common factors which were then simplified down to 2 and 5. Therefore, if we want to write the initial amount of candy that each person had, we can write this as 2x to 5x. And we can see that if we simplify 2x to 5x, the x's would cancel out and we would have just 2 to 5. We are then being told that Alice gave 80 candies to Bob. So from the initial amount that Alice had, which was 2x, she gave 80 to Bob, meaning she took away 80 from her. So we're going to write this as 2x minus 80. And because she's giving them to Bob, we are going to write this as 5x plus 80. So we are adding them onto the amount that Bob has. We've then been told that after Alice has given these candies to Bob, the ratio is then 1 to 3. So what we can do is now put this equal to 1 to 3. And what we are going to do is now write this as an algebraic fraction. So 2x minus 80 over 5x plus 80 is equal to 1 over 3. If we now cross multiply to make it linear, we will have 3 times 2x minus 80 is equal to 5x plus 80. Expanding the brackets, we will have 6x minus 240 is equal to 5x plus 80. If we minus 5x on both sides, we will have x minus 240 is equal to 80. And if we now add 240 to both sides, we will have x is equal to 320. So because the question is asking us how many candies did each initially have, the initial amounts were 2x and 5x, which means that Alice had 2x, which means 2 times our x, which is 320, and that gives us 640. Bob had 5x, which means 5 times x, which is 320, and that gives us 1,600. So now we have the initial amount of both candies that Alice and Bob had initially. In this question, we are told Emma and Grace share some stickers in the ratio 3 to 7. Emma gives 150 stickers to Grace, and now the ratio is 1 to 4. How many stickers did each initially have? So first we've been given the ratio of stickers which Emma had to those that Grace had, which is 3 to 7. Which means that the initial amount that they both had was 3x and 7x, x being the factor that was cancelled out in both of those. We are then told that Emma gives 150 stickers to Grace, so we are going to take away 150 from Emma's amount. So we're going to write this as 3x minus 150. And because she's given them to Grace, we will add this amount to Grace's amount. So we're going to write this as 7x plus 150. We are then told that after Emma's given the stickers, the ratio is now 1 to 4. So we can now put this equal to 1 to 4. And we can now rewrite this as algebraic fractions. So we can put this as 3x minus 150 over 7x plus 150 is equal to 1 over 4. We can now cross multiply this to get 4 times 3x minus 150 is equal to 7x plus 150. If we expand the brackets, we will now have 12x minus 600 is equal to 7x plus 150. If we then minus 7x on both sides, we will be left with 5x minus 600 is equal to 150. And if we add 600 on both sides, we will have 5x is equal to 750. We can then divide both sides by 5 to get x is equal to 150. So the question is asking us how many stickers each person had initially. And in order to do this, we have to use the initial amount, which is 3x and 7x. So Emma had 3x, meaning 3 times x, which is 150. And that gives us 450. So Emma had 450 stickers, and Grace's initial amount is 7x, meaning 7 times x. So we are going to do 7 times 150, and that gives us 1050. So the initial amount of stickers that Emma had was 450 and Grace had 1050. So here are a few practice questions for you to try. So please feel free to pause the video, grab a pen and paper and have a go at these before you resume the video to have a look at the worked solutions. Number 1 says, given that 2x plus 5 to 8 minus x is equal to 3x minus 2 to 8 minus x, find the possible values of x. So what we can do is first write this as an algebraic fraction. So we can write this as 2x plus 5 over 8 minus x is equal to 3x minus 2 over 8 minus x. We can then cross multiply this to make it a linear equation. So we will have 2x plus 5 times 8 minus x is equal to 3x minus 2 times 8 minus x. If we then expand the brackets, we will have 16x minus 2x squared plus 40 minus 5x is equal to 24x minus 3x squared minus 16 plus 2x. We can then collect the like terms on each side. So on the left-hand side, we can do 16x minus 5x, which gives us 11x minus 2x squared plus 40. And on the right-hand side, we have 24x plus 2x, which gives us 26x. And we can write minus 3x minus 16. We can then move the whole of the right-hand side to the left-hand side. So if we first add our x squared terms, so we can put it in a proper quadratic form. If we add 3x squared on both sides, we will have just x squared. If we take away 26x, we will have minus 15x. And if we add 16, we will have plus 56. This means we are now looking for two numbers that multiply to give us 56 and add to give us minus 15. And those two numbers are going to be minus 7 and minus 8. So we can now factorize this as x minus 7 and x minus 8. And if we want to solve this, we can see that if x minus 7 is equal to 0, that means x would have to be equal to 7. And if x minus 8 is equal to 0, that means x would have to be equal to 8. Number 2. Tom and Jerry share some marbles in the ratio 4:9. Tom gives 120 marbles to Jerry, and now the ratio is 2:7. How many marbles did each have initially? So we know that the ratio of Tom to Jerry's marbles is 4:9, which means that the initial amount that they had must have been 4x to 9x. This is the initial amount that they had, and we are then told that Tom gives 120 marbles to Jerry. So we can write this as 4x minus 120 for Tom, and because he's given them to Jerry, we can write 9x plus 120 for Jerry's. We are told that after Tom gives these marbles to Jerry, the ratio is then 2:7. So we can write this as equal to 2:7. We can then write this as an algebraic fraction. So we can write 4x minus 120 over 9x plus 120 is equal to 2/7. If we then cross multiply this to make it linear, we will have 7 times 4x minus 120 is equal to 2 times 9x plus 120. If we expand the brackets, we will have 28x minus 840 is equal to 18x plus 240. If we then minus 18x on both sides, we will have 10x minus 840 is equal to 240. And if we add the 840 on both sides, we will have 10x is equal to 1080. We can then divide both sides by 10, and that gives us x is equal to 108. So because the question is asking us to find how many marbles each person had initially, Tom had 4x, which means 4 times x. So we can say that Tom had 4 times 108, which is 432. Jerry had 9x, which means we can do 9 times 108, and that gives us 972. So now we have the initial amount of marbles both for Tom and for Jerry.